My name is Sachin. I come from a company called Elastic Run. We are based out of Pune. So yesterday, me and around 9 people were here for the contribution sprint. So this is the team. Okay. So I request Imanshu and Shivankar also to come on board. Okay. So I'll just quickly walk through what we did yesterday, and we have a separate talk planned on what we do and how do we use ERPNext. So basically, we try to solve one problem with ERPNext, which is basically a challenge, basically not a problem, of scaling ERPNext. So we recently started encoding some performance or scaling related problems with ERPNext. So we took up the challenge of scaling the ERPNext to the large and very large kind of deployments. So how do we scale any system? So one option is basically if you have a system which is bombarded with large number of requests, you can go and vertically scale the system. Okay, it will give you some leeway of handling more requests, but ultimately it will choke at some point of time, right? So if you are thinking of a very large deployment with a high throughput, how do we scale it? So I think the horizontal scaling is the only option that we have, wherein we can have a kind of a divide and rule strategy where we can divert users to different instances of ERPNext and get the job done. Okay, with of course everything is abstracted, right? So from the end user perspective, they are connecting to the same ERPNext instance, but ultimately there is a routing involved in between, which basically routes user to the specific ERPNext instance that they belong to, right? So this is what we did yesterday. I want to show a quick demo of it. I'll just log into. So we have 3 sites here. One is the master site. Second site is for. So what we did is we divided our users based on the state. Okay. Okay. So 2 minutes. So based on the state. So for one site we created for Maharashtra, one site we created for Karnataka, and there is one master site. So I'll just go to the master site first, and I'll show you the cluster configuration. Okay. So what we did is we added a new doc type called cluster configuration. So you go to cluster configuration. There are 2 clusters. One is cluster name image and cluster name KR. Okay, so once we do that, we can tag user to a specific cluster. So right now this is a static tagging. We can have any logic to tag a user to a cluster. So for example, Sachin is tagged to Maharashtra cluster, and Sagar, there's another user called Sagar which is tagged to Karnataka cluster. Okay, so this is a static tagging we have done, but there can be a better way to do that. Okay, so if I now go to my main site, which is er.com, and try to log in with user Sachin, it should take me to the Maharashtra site. Okay, so I log in as Sachin. Okay, so what it does is basically it goes to the main server for login. Then it determines what is the cluster that the user belongs to, and based on that it redirects to the right node of ERPNext. And for Sachin, since it was Maharashtra, it has taken it to the Maharashtra cluster. So you can see that Jai Maharashtra logo. Okay, now I'll just log out and log in as Sagar, who basically tagged to Karnataka cluster, and see how it works. So if you look at the URL is same. Okay, there is no change from the end user perspective. It's the same URL that is getting logged in. Okay, so now Sagar has logged in, and system determines that it is basically belongs to a Karnataka cluster, and it is redirected to the Karnataka. Okay. So this is very high level, basically a guideline or a picture that we want to basically take ERPNext to for large and very large deployment with a high throughput requirements. So with that, my time is up. So there is another point which I request Shivankar to take ahead, which we worked on yesterday. Okay, you can use this. Thank you.
Yeah, hi guys, myself Shivankar from Elastic Run. So another problem that we have tried to solve is the tab name series problem. So right now a lot of tables and all the doc types are series based. Even the child tables are hash based or series based, which actually when we are having multiple 100 user 200 users, it creates problems because of the locking. So we have introduced new type, that is auto-increment. So it uses database auto-increment feature, and it gives the ID automatically. So currently, like if there are 100 requests that are coming, and that blocks the tab series, so only one can pass at a time. And because of auto increment, all the there are no locking introduced, so directly it goes through the database, so it helps in the performance. So this is when we have auto increment implemented. So there is a so I've created a doc type for student. So this is the basic data that we are sending, and this particular doc type has auto increment. So the configuration is based actually. So number of threads is 200 users and 5 requests for per user. So the report summary is, so 100 requests are thrown. So error is 0 and throughput is 22 requests per second.
So basically, what is done is like we created a sample doc type, two doc types, one doc type with the naming series and one doc type with auto increment, and we fired 200 threads, each thread bombarding 5 requests, and we compared the results of that. So the first test was with the naming series doc type. So the throughput that we could achieve was 7.4 requests per second, only 7.4 requests per second. The moment we changed the naming series to auto increment, that same throughput went to up to 23 requests per second. So it's a huge performance improvement. And this will get benefited for almost all doctors where we have child tables. So any child table does not require a naming series, can be auto increment. And plus we can have a selective doctors to which we can use this auto increment feature, which will avoid the potential locking. Okay, thank you.
Thank you guys.
Hi all, I'm Himanshu from Elastic Run team. So, in any big business, reporting and monitoring are a big part of big and essential part of the organization. Everybody has to constantly know in the real time what exactly is going on the ground. Okay, so in our business, we have been dealing with the millions of data points. So there's a report called there's this report called stock balance, and there were a few reports that we built. Okay, so they were churning almost 10 lakh, which is a million entries in real time, and they were being used by multiple people. So the impact that it had on our system was कि whenever somebody used to open a report, rest of our system used to go downhill, and the transactions would be blocked as the system was occupied by the reporting itself. So this contribution was not made in the last 2 days. This was an earlier contribution which was basically made by Frappe team themselves when they came to our office. Okay, so the contribution was introducing a frappe.read-only decorator in the Python functions. So what that decorator does is, so this is how you implement that decorator. You have to simply add a frappe.read-only flag, frappe.read-only decorator on top of your function. And what exactly it will do is, it'll split your read-only calls, which are basically reporting calls. Well, this particular function which you decorate with frappe.read-only, the calls that it makes to the database will be redirected to another server, which can be replica of your primary server. So what it will do is कि your primary server can better serve off the transactions, while the replica, which can be pumped up or beefed up, can serve the higher volume reporting calls. So it helps you scaling. It also helps you scaling the ERPNext in terms of enterprise architecture. Thank you.